Hello everyone, myself Assistant Professor Vatsal D. Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about theodolite traversing. So our today's topic is adjustment of theodolite, both the temporary and permanent. Okay, so be ready with your pen and paper. So let us start with the temporary adjustment of the theodolite. So in temporary adjustment, it is the adjustment which are required to be made at each setting of the instrument before taking the observations. These adjustments are also known as station adjustment. So such adjustment involves the following step like setting up, centering, leveling up, focusing the eyepiece, focusing the object glass and elimination of parallax. Okay, so let us discuss each and every step. So the first one is setting up. So first tripod is set up. Okay, so you can see it here in the image. Okay, so place the tripod over the station. Say our station is here. Okay, which is marked here black one. Okay, so the legs of the tripod should be spread so that they make an angle of 60° with the horizontal. So the angle of the legs will be 60° approximately, okay, with the horizontal. Next, the height of the tripod should be kept average, say 1.2 meters. So here we can see the height of the man and height of the tripod. Okay, so eye level should be there. Okay, so approximate height will be 1.2 meter. Okay, next the theodolite is then lifted from the box and fixed on the top of the stand by means of wing nut or according to the arrangement provided along with the instrument. Okay, so here you can see the theodolite is not here. Okay, so after setting up the tripod we will move to the next step. Okay, so next the legs of tripod stand are placed well apart and firmly fixed on the ground. Then approximately leveling is done using this stand. To do this, two legs are kept firmly fixed on the ground and third is moved in or out clockwise or anti-clockwise so that the bubble is approximately at the center of its run. So here we can see the equal spacing is here. Okay, so there will be firmly fixed two tripod legs. Okay, and third one is moved clockwise or anti-clockwise according to the adjustment of level, and when the level is get, the adjustment is said to be done. Okay, next process is centering. Okay, so here is the zoom out image of the center. Okay, so what we have to do, we have to center this instrument to the station. Okay, so first one, our center is not in the center. Okay, it is here, so we have to do adjustment at which the place come in the center. Okay, so let us see its procedure. So we can see here the theodolite is already adjusted on the tripod stand as we discussed in previous. Okay, so centering is the process of setting of the instrument exactly over the station. Okay, so to exactly put the instrument on the station is known as centering. So the operation with vertical axis of theodolite represented by a plumb line is made to pass to the ground station mark is called centering. Okay, so here we can see the plumb line will be at the center. Okay, so what we have to do, we have to do the plumb line should be at the center. Okay, here we can see plumb line is not in the center. Okay, so we have to make adjustment by moving the tripod legs in or out, okay, clockwise or anti-clockwise. Okay, and then the centering will be done. Okay, so let us see. So at the time of approximate leveling by means of the tripod stand, it should be ensured that the plumb bob suspended from the book under the vertical axis lies approximately over the station peg. Okay, so in modern theodolites the shifting head is provided for easy and accurate setting of the instrument. In some instruments, centering can be checked by optical plummet also. Next is leveling up. So after having centered and approximately leveled the instrument, accurate leveling is done with the help of foot screw and with reference to the plate levels. The purpose of the leveling is to make the vertical axis truly vertical. Okay, so let's see its process step by step. Okay, each and every step is important. Okay, so be sure you write down all the steps. Okay, it is very important for the examination. Okay, so let us start with the first step. So turn the upper plate until the longitudinal axis of the plate level is roughly parallel to the line joining any two of the level screws, say A and B. So here we can see in the image. Okay, so foot screw A and B is here. So what we have to do, first of all, parallel to the longitudinal axis of the theodolite. Then second figure we will take its perpendicular. Okay, so first step we have to take the line parallel. Okay, level tube parallel, bubble tube. Next step 2 is hold these two leveling screw between the thumb and first finger of each hand uniformly so that the thumb moves either towards each other or away from each other until the bubble comes to the center. So here we can see the foot screw is here. Okay, so we have to move foot screw, both the foot screw at same direction. Like if we moving outwards, it should both the foot screw should move the outwards. If we move it inwards, so both the foot screw will be moved inwards. It is not like that you move this one away and this one in. Okay, so in same direction we have to move the foot screw. Okay, so it is the step 1. Next, step 3, turn the upper plate through 90 degree. For example, until the axis of the level passes over the station of the position of the third leveling screw, say C. Okay, and step 4 is turn this leveling screw until the bubble comes to the center. Okay, so here foot screw A, B and C is here. So first what we have to do, put it parallel to the foot screw A and B, and the bubble tube is here and we can see bubble is here in the center. Okay, next put it to the parallel to the line AB. Okay, so it is according to C. So here we can see bubble is in the center. So in this way all the process is done for the leveling up. Okay, so for each and every leveling we have to do all leveling, like first of all line AB, then AC and then BC. Okay, same procedure. Next, step 5. So rotate the upper plate through 90 degree to its original position. Say figure A is here. Okay, and repeat the step 2 till the bubble comes to the center. So what we have to do, rotate to plate through the 90 degree as we see here in the image. Okay, and then repeat the step 2, which is our step 2, foot screw. Okay, move inward or outward, same direction. Okay, next number 6, turn back again through 90 degree and repeat the step 4. So what is our step 4? Turn the leveling screw until the bubble comes to the center. As we discussed, we have to do this process 3 times. Okay, so we are doing the same procedure. Okay, again and again. So next repeat the step 2 and step 4 till the bubble is in center in both the position, like perpendicular and parallel both. Okay, now rotate the instrument through 180 degree. The bubble should be remaining in the center of its run, provided it is in correct adjustment. The vertical axis will then be truly vertical. So if we rotate the instrument through 180 degree, the bubble should be remain in center in all the way. Okay, all the direction. Like if we talk about line AB, so that will be in same position, like BC will be there and CA will be there. So it is then called perfect leveling. Okay, next is focusing the eyepiece. So the eyepiece is focused so that the crosshair can be seen clearly. Okay, so the telescope is directed towards the sky, not against the sun. Remember that. Okay, or a sheet of white paper is held in front of the object glass. Okay, so the eyepiece is moved in or out by turning it clockwise or anti-clockwise until the image is clear. Okay, so what we have to do, first of all, eyepiece, the objective focus is here. Okay, so we have to rotate that focusing screw and be sure that sheet of white paper is there and we can clearly see its image. Okay, next is focusing the object glass. So the telescope is now directed towards the object to be sighted. Then the focusing screw is turned clockwise or anti-clockwise till the image of the object or target appears clear and sharp. So the image so formed is in plane of crosshair. So we can see before the adjustment the image will be hazy and after the adjustment image will be very clear. Okay, so we can see difference here. Okay, next is elimination of parallax. So parallax is a condition arising when the image formed by the objective is not sorry, parallax is a condition arising when the image formed by the objective is not in the plane of the crosshair. So we can see here in the image. Okay, so parallax elimination will be there because it is not in the same line, so it is somewhat move upwards. Okay, unless parallax is eliminated, accurate sighting is impossible. Okay, so we can see here in the second step it will move downward. Okay, so approximate reading we cannot take or sighting we cannot done. Okay, so elimination of parallax may be done by focusing the eyepiece for distinct vision of crosshair and focusing the objective to bring the image of the object in the plane of the crosshair. So we have to do all the arrangement and do the adjustment in which crosshair focusing objective bring both image at the same crosshair. Okay, same plane of crosshair. So it is known as elimination of parallax. Next we are going to discuss about setting the vernier. Okay, so after this setting the vernier is the next step, which is the main one. Okay, so the vernier A is set to 0 degree and vernier B is 180 degree. Okay, so to do this, first release or loose both the clamp screw, then the lower clamp is fixed, then the upper clamp is loosened and the upper plate is rotated until the arrow of vernier A approximately coincide with the 0 or say 360 degree and that of the vernier B approximately coincide with 180 degree mark. Then the upper clamp is tightened and by turning the upper tangent screw, the arrows are brought to a position of exact coincidence. Okay, so all the setting is done by like this. Okay, and then the readings are taken. So before taking the reading, this is the main procedure we have to follow. Okay, next we are going to discuss about function of clamp screw. Okay, so when the upper clamp screw is tightened but the lower clamp screw is loose, the instrument rotates on its outer axis without any relative movement between the two plates. It is called lower motion. So in this case there is no change in vertical reading. Remember all this, okay, because it is very important when you operate the theodolite. Okay, so we have seen here the function of clamp screw. Next, when the lower clamp screw is tightened but the upper clamp screw is loose, the instrument rotates on its inner axis with a relative movement between the vernier and the scale. It is called upper motion. So in this case there is change in vertical reading. First we have change, there is no change in vertical reading. Okay, when the upper clamp screw is tightened. Next, when lower clamp screw is tightened, then there is change in vertical reading. Okay, next, when both the upper clamp screw and lower clamp screw are tightened, the instrument cannot rotate at all. So in this case force should not be applied to rotate the instrument. So what we can learn from here, like when the both upper and lower clamp screw are tightened, the instrument cannot rotate. Okay, so you cannot force the instrument to move. Okay, because it may break down its setting. Okay, so be sure which clamp to loose and which clamp to tighten. Okay, according to the requirement. Next, we will discuss the function of tangent screw. So, for small movements of plates, corresponding tangent screw are used. Before using any tangent screw, the corresponding clamp screw must be tightened first, otherwise it will not work. Like if there is some elimination, okay, or say not accurate reading, so then the tangent screw will be used. Okay, so after clamping the lower clamp, fine adjustment of the lower plate for bisecting the target or say ranging rod can be made by rotating the lower tangent screw. And after clamping the upper clamp, fine adjustment of upper plate for bisecting the target, say ranging rod, can be made by rotating the upper tangent screw. So according to requirement, upper clamp screw and lower clamp screw of tangent screw is used. Okay. Next, we will discuss the permanent adjustment of the theodolite. So, a theodolite consists of several fundamental lines. So, in order the readings to be accurate, certain desired relationship must exist between the fundamental lines of the instrument. But due to improper handling or excessive use, this relationship may be disturbed and hence from the theodolite may lead to erroneous result. So if we do not do this, then there will be error in our results. Okay, so desired relationship there. Okay, so the desired relationship of the fundamental lines are there. Okay, so the fundamental lines of theodolite are mainly vertical axis, horizontal axis or say Trunnion axis, line of collimation or say line of sight, axis of plate level, axis of altitude level, axis of striding level if provided. Okay, so let us discuss desired relationship. Okay, so fundamental lines of a theodolite is shown here. Okay, so see this image, it is very important for the examination and theory. Okay, so be sure you mention each and every axis according to its position. Okay, so remember this figure or say image. Okay, so let us discuss its relationship. So the axis of the plate level must lie in a plane perpendicular to the vertical axis. The line of collimation must be perpendicular to the horizontal axis. The line of collimation, the vertical axis and the horizontal axis must intersect at a point. The horizontal axis must be perpendicular to the vertical axis. The axis of the altitude bubble must be parallel to the line of collimation. And the vertical circle vernier must read 0 when the line of collimation is horizontal. Okay, so all the desired relationship is here shown here in the image. Okay, so be sure you maintain all this desired relationship. Okay, next we start with the permanent adjustment of theodolite. So let us discuss it step by step. So first one, adjustment of the horizontal plate level is there. So plate level test to mark the plate level at the center when the vertical axis is truly vertical, it is done. Okay, next is adjustment of line of sight or say collimation adjustment. So crosshair ring test to make the line of collimation coincide with optical axis and also to ensure that the line of collimation generates a vertical plane when the telescope is transited. Okay, next is adjustment of horizontal axis. So spire test to make the horizontal axis perpendicular to the vertical axis, it is used. Next is adjustment of altitude level. Okay, so collimation test to make the line of collimation perpendicular to the horizontal axis. Telescope bubble test to center the telescope bubble when the line of sight is horizontal. And last one is vertical circle index adjustment. So vertical vernier test to ensure that the vertical circle reads the 0 when the line of sight is horizontal. So these are all the permanent adjustment of the theodolite. Okay, so here are the important questions which can be asked in the examination. So be sure you see all this, and as we already seen all this theory and discuss all these question already in this video. Okay, so note down these questions. Okay, so here I end my session. Thank you all of you.